Hey, this is Mr. Ward, and I'm doing a video key for Geometry Do Now 22.2. Let's go ahead and talk through this. So I am reminding you of this definition that a line perpendicular to a plane is also a line perpendicular to every line on the plane that passes through its foot. So AB if AB is perpendicular to plane M, then it is also perpendicular to EB, CB, and DB, because they all pass through its foot, which is B, the point where the line intersects the plane. So we're going to use this definition and what we know about triangles, especially the hypotenuse leg postulate and the characteristics of an isosceles triangle, to prove that A here is equidistant to B and C. And drawing some auxiliary lines will help us. So let's start off with the givens. So we know that PA is perpendicular to plane S. That's given to us. We know that P here is equidistant to B and C. So we could draw lines here and here that would communicate that. We know now this one is not a given. This is the next thing. PA is congruent to itself because of the reflexive property. Now, PAB and PAC, these angles here are both right angles and congruent because a line perpendicular to a plane is perpendicular to any line on that plane that intersects with its foot. And A is the foot of PA. It's where it intersects plane S. And BA and CA are lines that intersect with PA at its foot. So therefore, they are perpendicular to PA. And perpendicular means right angles. So now, with that, we can actually prove that triangle PAB, we can draw a line here, and triangle PAC are congruent because PC and PB are congruent, and PA is congruent to itself, and these are right triangles because of the right angles here. Once we've got that, okay, once we've got that, we can say that AB and AC are congruent to each other because they are corresponding parts of congruent triangles. Then finally, A is equidistant to B and C, definition of equidistant. So I'll recap that with some drawings. I'll walk that through. So we know this. We know PB and PC are congruent because we've been told P is equidistant to B and C. Okay. We also can state that PA is congruent to itself. And we know that this is a right angle, and this is a right angle. So now we've established that PAB and PAC are right triangles. We have a hypotenuse and leg, hypotenuse and leg. So hypotenuse, leg, proof for those two triangles. And then with that, we can use kappa to say that AB and AC are congruent. Okay, so kappa right there. And since they are congruent, A is equidistant to B and C. Now let's go to the next one. I hope that clarified that. Let's look at this next one. We're going to want to remind ourselves of Theorem 40. A line is perpendicular if a line is perpendicular to two distinct lines that lie in a plane and that pass through its foot, then it is perpendicular to the plane. So this line, if this line is perpendicular to BF and also CF, and BF and CF lie on the plane, okay, then we can establish that AF is perpendicular to plane M. So let's see EF. EF is going to bring us to a proof where we got to prove that EF here, number 2, EF has to be perpendicular. We're trying to prove that it's perpendicular to plane M. So to do that, it would be helpful to prove that DF and CF are perpendicular. We already have EF as perpendicular to CF, but we don't have that it's perpendicular to DF. To do that, to prove that, it would help to prove that triangle EFD and EFC were congruent, because then we could use kappa to prove these angles are right. So let's see what we've got. Okay, so first of all, we know that EF is perpendicular to CF. That's a given. And we know that CE is congruent to DE, which, by the way, is going to make this thing an isosceles triangle. That's true. Then we know that FCD is congruent to FDC, which tells us, by the way, that FCD will be an isosceles triangle because that base and that base angle here are going to be congruent. And that'll also mean that CF and DF are congruent. Oops. Accidentally putting the form in. Okay, now we know that triangle CDF is isosceles, and the base angle, because the base angles are congruent here. That's what this statement, angle FCD and angle FDC being congruent, gave us. Now, CD, I'm sorry, that should say CF. CF, and it's going to object to me changing it, but CF is going to be congruent to DF because that is isosceles. So that was a typo on my part. Okay, I'll have to fix that at the end. I'll come back to that. That should be an F, not CD. Now, we also know EF is congruent to itself because reflexive. And I'm Control-Zing my way through this, by the way. You may have figured that out. We now can say that triangle EFC is congruent to triangle EFD because all three sides are congruent. We were given CE and DE. The isosceles triangle down here gave us DF and CF, and reflexive gives us EF. Now, we can then say angle EFC and angle EFD are congruent by kappa. And therefore, EF is perpendicular to plane M because EF is perpendicular to two distinct lines, CF and DF, which lie on plane M. That's Theorem 40. Now, I'm going to go ahead and fix this. That should have said CF. And let's go ahead and label the heck out of this thing. So we know that that's a right angle. We also know that CE, this here, is congruent to this. And we know that this angle is congruent to this. This is all based on the givens. Okay, now let's look at what else we can say. So after we've gotten through the givens, we can say triangle. I'll go ahead and add that as a given. Okay, we can say triangle CDF is isosceles, but we know the base angles. So, and then because of that, we can say that because CDF is isosceles, we can also say DF and CF are congruent. So let's label that. So this and this, those are congruent. I'm going to undo that last one. I guess I can't. Nope, it's not going to let me do that. That's going to be messy. Okay, so we know that this and this are congruent. And we know that EF is itself. So mark EF as itself. I'm going to use a color that's a little more distinct. So EF is itself. Okay, and now we have side, 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 and side, side, side. So we're able to prove that these two triangles, EFC and EFD, were congruent. And then finally, we can say that I'll use blue here. We can now say that this angle and this angle are congruent, and they're both right angles because they're congruent. It's congruent to a right angle, and therefore EF is perpendicular to plane M because it is perpendicular to two distinct lines that lie on the plane M, and therefore it is perpendicular to M. I hope that was helpful.